In this video, we're going to practice taking measurements employing the significant figure technique. Remember, significant figures, or sig figs, include all of the certain digits plus one estimated digit. So let's go ahead and measure the length of this arrow. Looks like the arrow stops about right there. So this would be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. So it's somewhere between 2.5 and 2.6. So we know for certain 2.5. Now we have to estimate one place. So I thought that the length was 2.58. We knew 2.5 for certain, and then this value here in the hundredths place, that's an estimation. Okay? Now you try one. Go ahead and pause the video now. It looks like to me like the arrow ends right there. So this would be like 3.5, 3.6, 3.7, 3.8, 3.9. This would be 4.0. So we know 4.0 exactly, and then we have to estimate one place. So hopefully you got 4.00. Okay. Significant figures works the same way, whether you're measuring length or whether you're measuring temperature or volume or anything else. So to me, it looks like the thermometer reads, this would be 20, 21, 22, 23. It looks to me like it's exactly 23, and we can read 23 for certain, so we have to say 23.0. This is our one estimation here in red. If you put 23.1 or 23.2, that's fine too, as long as you have something in the tens place. All right, why don't you give this one a try? Go ahead and pause the video now. Okay, if this is 60 and this is 61, we know 61 for certain, and it looks like our temperature is somewhere between 61 and 62. So I'm going to estimate 61.3. Once again, if you have 61.2, that's okay. It doesn't matter what's here as long as you have some estimation in the tens place. Now, reading from this beaker, it's a little bit tricky. Let's try to figure out what we know for certain. Well, this would be 20, 30, 40, 50. So it looks like we only know the tens place for certain. We know that this volume is somewhere between 40 and 50. So what's a number between 40 and 50? Well, to me, it looks like it's close to 50, so I'm going to say that it's 49 milliliters. Notice that this 9 is an estimation. So if you thought this was like 49.5, that's too much estimation. We don't even know for sure that this is a 9, so we certainly can't begin to estimate anything more precise than this place here. That doesn't make any sense. So you won't be reading volume from a beaker very often because it's a pretty imprecise measurement tool. All right, this is reading from a graduated cylinder. Anytime you have water in a graduated cylinder or some type of narrow capillary tube like this, you'll see the water forming a meniscus. You always want to read from the bottom of the meniscus. Additionally, you want to get your eye down at the same level as the meniscus so you're not reading at like an oblique angle or anything like that. So let's see what we have here. This is 30, 31, 32, 33, 34, 35, 36, and that's 37. So we know 36 for sure, and then let's estimate some. So let's say 36.5 milliliters. All right, well, why don't you give this one a try? Go ahead and pause the video now. Okay, here's what I would say. I would say 40, 41, 42, 43. To me, it looks like it's exactly at 43. So we know 43 for sure, and then let's estimate one more place, 43.0. Okay, lastly, this is what it will actually look like in the lab. I attempted to take a picture. It's a little bit hard to read, but here we go. This would be 5.0. This would be 5.1. To me, it looks like it's pretty much at 5.1. So if we can read 5.1 for sure, we have to include the estimation. So the volume here, reporting the correct number of significant figures, is 5.10. And however many decimal places you're able to read to, that's the degree to which the instrument is precise. So you can see that this graduated cylinder is precise to the hundredths place.